To solve a right triangle, the definition means to find the measure of both acute angles and the lengths of all three sides. So in other words, you're going to know every angle and every side length when you're done with the problem. Solve a right triangle to find the measure of both acute angles and the lengths of all three sides. Some of that information will be known. Like, what do we know on this problem so far?
It's a right triangle.
Okay, we know it's a right triangle, so we know this angle's 90. And we also know another angle is 65 degrees. Oh, how do you get the other one to be 25? Okay, triangle sum theorem. Okay, so now we know all the angles. We know the hypotenuse is 15. The hypotenuse is always the longest side in a right triangle, yes. Okay, let's try and find the missing sides. Let's try and find this one. Now that we have both or all three angles in there, you have to decide which angle you want to be using. And you're not going to be using, if you're doing the trig ratios, you're not going to be using the 90 degree. You're going to use either the 65 or the 25. I'm going to use the 65. What trig ratio would I use to find x? Which one do you think, Shreya? Cosine? Do you agree with her? Okay, cosine is right because x is adjacent and the 15 is the hypotenuse. So let's see, you said cosine. Cosine of 65 over 1 is equal to x over 15. So to find x, we have to take 15 times the cosine of 65. Let's go tenths, I think. 6.3. I think that's where they do most of them. 6.3 centimeters. Do we know everything of the triangle yet?
No, we need the other side.
We need the other side. Okay, I'll put a y there. You want to use the 65 degree angle still? Or is there another way? Let me mention, we just found this to be 6.3.
We could use any of them.
We could use any, you could even use Pythagorean theorem. Recognize Pythagorean theorem? You could do 6.3 squared plus y squared equals 15 squared. You want to do a trig ratio or Pythagorean theorem? You want to do Pythagorean theorem? Okay. So let's go 6.3 squared plus y squared equals 15 squared. 6.3 squared. 39.69. 15 squared, I think, is 225. Okay, so 225 minus 39.69. 185.31. That's what y squared is. How do you get y? You have to square root it. So square root and one decimal place, 13.6. So 13.6. Notice what we've got now is we know every side length and we know every angle. We just solved the right triangle. Did we do anything new there that was different than what you did the last few days? No, we really just did all of it instead of just one side or two sides. Okay? Question on that one? People done with their notes? so when are we going to have to do something that's new? Well, the new part is if I give you only the 90-degree angle, I don't give you another angle, that's the new part. Triangle sum theorem, if you know two angles, you can find the third one. But if you only know one, can you figure out what the other two are? You can figure out what they add up to be, but not be sure which values they are. Okay? So we'll take a look at one of those next, I think. All right, am I ready? Is that what you need? Okay, so let's try and solve this triangle. Yeah, write this as an example. I mean, you don't have to do all the notes there, but that kind of tells us we're going to have to do what's called an inverse. Tangent inverse is actually what we use. But what can you find? Help her out. Pythagorean theorem is what she was trying to spit out. Okay, you can find the other side by doing Pythagorean theorem. Everybody do that for me. Do the Pythagorean theorem and find the missing side. Got 8 and 15 written down. I'm going to align this screen while you're working. Okay. All right, so when you're doing Pythagorean theorem, what did you get the hypotenuse to be? Yeah, I think you're right, because it's the square root of 289. Okay, hypotenuse is 17. Now we would get stuck because there's no way that we know of to do the rest. So it says solving this right triangle requires finding an acute angle. To do this, in this problem, we need to use the inverse tangent function. Okay, so here's what we're going to do. To find this angle right here, we will do the tangent inverse. And what we have to do, tangent inverse is going to tell us the angle. We have to tell it what the tangent is. So what's the tangent, what over what, for this angle? Tangent is opposite leg over adjacent. So what's the opposite leg length from this angle? 8, and the adjacent leg? 15. Okay, so on your calculator, tangent inverse, you have to usually hit second or shift to get to that. Either before or after, depending upon your calculator. A lot of you, the ones that write in the screen, activate the tangent inverse and then tell it the fraction 8/15, and it'll tell you the angle. On the one I'm using, I have to do 8 divided by 15, get that, and then do shift or second tangent. I get a 28-degree angle. You don't have to make it as a decimal. I'm not sure if your book goes one decimal place on angles. I know our regular geometry does not. I think yours does. Yours says tenths on your angles. So 28.0 is, no, that would be 0.1. That'd be 0.1. 28.1. And then now how about the other angle? Don't we know this one's 90? And this one was 28.1? Someone mentioned earlier we could use triangle sum theorem. So subtract 180 minus 90 and minus 28.1. What's left? 61.9. And we have solved the whole triangle. We have all the angles, we have all the side lines. So what was different on that one? Had to find that angle. And in that case, we did the tangent inverse to find the angle. You might notice on your calculator, there's a sine inverse and a cosine inverse and a tangent inverse. You could use any of them. How could we have used a different one? Let's say we wanted to use sine inverse to find the same angle. Well, what would the sine be? What over what? Opposite would be 8. 17 would be hypotenuse. So try on your calculator the sine inverse of 8/17. Does that still give you the 28.1? It should. But you need to do the second with it to get, see it says sine -1. Sine inverse. And then do the 8 divided by 17.
I can't get it to work on.
Can't get it to work on there. Are you getting the sine inverse activated?
Yeah, I have to work it out.
Okay, so you have to do 8 divided by 17 equals. Now do second sine. You just hit tangent. If you're doing 8/17, which problem are you doing? The tangent inverse or the sine inverse?
Uh,
Then I put your wrong number in.
okay.
Calculators to do this. You're gonna have to have a calculator for this part, right? If you need a calculator, I have like 2 available. I don't have enough for everybody every day in here. Gotta bring some. Okay, and one more to try. What if you were doing cosine inverse? Cosine. Cosine is adjacent over hypotenuse. So that would be 15/17. So cosine 15/17. So which one to use is up to you. Not always will you have all 3 numbers. Yes?
Why is it a -1?
That's called that's just the notation for inverse in this situation. That's what's called, that's the notation that is used for the inverse. And what it's doing is reversing the sign. Instead of you giving it the angle and the calculator tells you the sign, you're telling it the sign and it's telling you the angle, which is kind of like a converse in other order. But inverse is the term that was used right here. Okay, looks like we're done with that one. So as far as notes, the inverse tangent theorem. If the tangent of A is z, or some number, then tangent inverse of that number gives you the measure of angle A. In other words, you use the inverse when you're trying to find an angle measure. So you might put use an inverse to find an angle measure. Let me write that instead of this sentence. That's the tangent inverse. Probably on my next screen, there's a screen with sine inverse and cosine inverse also. So let's put an actual example up there. So I'm trying to decide how I want to write it. I think your book will say something like, if the tangent of A is 5/12, then the measure of angle A is tangent inverse of 5/12, which is what? Now you've got my calculators. So what angle has a tangent of 5/12? 2.6? Does that help make sense out of what the notes are saying? So I think some of the problems on your homework are going to say, the directions will say find the angle, and it'll say the tangent of A is 5/12. So you're supposed to find the angle. So this is what you need to do to find the angle. Morgan? No, I'm not gonna get real picky, but when would you use approximately? Yeah, if you have to do some rounding. Okay, Carrie?
Would we have to write out like tangent rays or
Oh, this right here?
equals that, or could we just write that?
I think it would be better if you write this.
Okay,
If you're writing this, that's showing me what you're doing.
okay.
All right, I think there's some notes about sine inverse and cosine inverse also. Let's go to those. So, this is mainly, these two things are just like you wrote related to tangent. So if the sine of an angle is y, then sine inverse of that y gives you the measure of the angle. And same with cosine. If you know the cosine of the angle, then cosine inverse will give you the angle measure. Now, writing those down or reading that probably doesn't maybe make a lot of sense until I put the number in there. You're putting a number in to help it make sense, that's fine. Okay, so then we'll go back to a few example problems where we have to find some angles. So I want you to find the angle. I think I'll go to the board for just a little bit while some are finishing notes. Okay, I'm gonna tell you the cosine of A is 0.6247. I want you to tell me the measure of angle A. How many degrees is the angle if its cosine is 0.6247? Got it yet? Are you doing cosine inverse of 0.6247? 51.34. Directions will probably say tenths, so 51.3 degrees. Degrees because you're finding an angle. Okay. All right, if the tangent of angle B is 4.23, I want you to give me the measure of angle B. What do you need to do? Tangent inverse of 4.23, which is, I probably should put approximately because we're most likely rounding. Zach? What's it come out to be? 67.6? No? 76.6? Okay, just reading it wrong. Okay, and what if I said the sine of C is, let's see, I think I have to go 0.4621. What's the measure of angle C? Find the angle, do sine inverse. 0.4621. What angle has that as a sine, buddy? 7.5 degrees. Okay, got that part? All right, so let's do a triangle. Find the measure of angle A. How many degrees is angle A to the nearest 10th? Decide if you would use sine inverse, cosine inverse, or tangent inverse. Depends what sides there are. The 26 would be opposite. The 7 would be adjacent. Trig ratio that uses opposite and adjacent. Tangent. Opposite and adjacent. I'm looking over there on that side of the board. So let me find the angle. So to find the angle, you have to do an inverse. I decided it was tangent because I have opposite and adjacent as my two lengths. So to find the measure of angle A, I'm going to do tangent inverse. I'm going to tell the calculator what the tangent is, and it's going to tell me the angle. This time it's going to be in fraction form. Opposite, 26. 7 is adjacent. So calculator, what angle has a tangent of 26 sevenths? 74.9? Would it, what's after the 9? A 3? Okay, so it wouldn't go up. Okay, question? No? Okay, let me do one more example, and I know we're kind of using up class time here, but I think if we don't, you're going to have lots of questions. Solve the right triangle. Let's just find one more angle. Let's have you find this angle if this is 16 and this is 7. We're not going to solve the whole thing. Find angle A. How big is angle A? Decide if you're going to use sine, cosine, or tangent. Is it sine, cosine, or tangent that's involved? Sine? Correct, because this is opposite leg and this is hypotenuse. So to find the measure of angle A, sine inverse of 7/16. What angle has that as a sine? 25.9, agree with her? Okay. 25.9. Then we could solve the rest of the triangle if we needed to, right? Okay, let's have you get to some of the problems because some of those that we were doing here, you can do very quickly. On page 572, starting with problem 10. 10 is a solve the right triangle, so if we want to do that one together, we can do that. Number 10. Kind of confusing, it has the little XYZ and the big XYZ. Okay, what do we need to figure out on 10? The directions say solve the right triangle, which means find all the angles and all the sides. That's the right problem, isn't it, to start? Okay. Your book is different on page 572? Oh, go down into the actual exercises. Yep, up at the top is a checkpoint that has a number 10. Yep. Glad we caught that. Okay, so how do we find, you can find the other angles for me. Right? Angle Z is 90. How many degrees is angle X? 30, because it has to add up to 180. Okay? Let's try and find X. Do you want to use the 30 or the 60? 30? Okay, if we use the 30, side X would be opposite. Side 4 that we know would be not adjacent, hypotenuse. It's not a leg. So which trig ratio with opposite and hypotenuse? Opposite and hypotenuse? So a sine. Sine of which angle were we using? The 30. Why did we use the 30? It's just what Tim picked for us. So 30 over 1 equals X over 4. So to find X, it says take 4 times the sine of 30 degrees, which is 2. And Y, how do we find Y? Could use tangent, could use Pythagorean theorem, could use sine, could use tangent, I don't care. Which angle do you want to use, or do you want to use Pythagorean theorem? Use sine? Are you doing the 30 or the 60? Okay, Carrie's making it confusing. She's going to the 60.
Oh,
We were on the 30 just a second ago.
That'll be sine 60.
So this one would be opposite. You want to use the hypotenuse, okay? So she's using opposite and hypotenuse. It's just what she's choosing. So she is using sine, her favorite trig function. Y over 4. Okay. So 4 times the sine of 60, what are you getting? 3.5. Could you have done Pythagorean theorem? Yeah. Let's see, a squared.
Did you leave that in radical form or not?
In radical form, what did the directions say? So no, it's saying decimal. So you could have done Pythagorean theorem. That was a 30, 60, 90 triangle. We could have used one from Lord. Could have done that too. Notice the short leg was half of the hypotenuse. Okay? Use some of your 5th period time for your math today. You have some excess time.